All right, let's go ahead and get started. Welcome to our webinar, everyone. My name is Justin D'Souza. I'm a quantitative specialist here at Statistics Solutions. During today's webinar, we are going to discuss SPSS data cleaning and management steps. We'll also take a brief look at assumption checking. So we're going to be recording this session, so you don't have to take a ton of notes. We'll be sending you a copy of the recording. At the end of the session, I will be doing a Q&A. So if you have any questions as I'm going through the slides, you can type your questions into the chat box and we'll do a question and answer session at the end. And just let us know if you have any questions. All right. So first, I'll discuss the services that we provide at our company, Statistics Solutions. Then we'll dive into today's topic, which is looking at SPSS and data cleaning. Then we'll conclude with a summary and a Q&A session. So on this slide, you can see all the various parts of the dissertation journey that we assist with, starting with topic development and going all the way to final defense and everything in between. So we have methodologists at our company, both quantitative and qualitative, and we have literature review specialists. So no matter where you are in the process, if you've hit a roadblock, we can certainly assist with you there. We can help you frame research questions, figure out what is the best data analysis approach you need to use to address your research questions. And then we can even help you find articles to support your research, and we can crunch the data for you and present the findings in an APA write-up. So just let us know if you have any questions about the support. You can give us a call at this number at the bottom, 727-442-4290. And on this slide, you can view the past webinars we've done in the webinar archive. So here we've done various topics. We've covered literature reviews, methodologies, results, how to communicate with your committee, setting up timeframes and plans. So we've done webinars on various topics for the dissertation journey. You can check that out here. So let's dive in. So the first thing we should discuss is planning. So if you're at the data analysis stage, it's important to first lay the foundation. So you want to have a methodology in place and you want to have a data analysis plan in place. So usually that's chapter 3 of a dissertation. You want to have an approved chapter 3 before diving into your data. And there's many reasons for this. You don't want to just collect data and start running things without having research questions and hypotheses. Otherwise, you'll be fishing for significance, is what it's called, where you don't really have a purpose statement or you don't have hypotheses. You're just looking for random significant relationships. That's kind of frowned upon in the statistics world. So you want to have a plan in place, and you want that plan to be approved by your methodologist and your chair. So within chapter 4, which is the results, I would suggest asking for a template for one thing from your school, and ask for previously approved results chapters that you can review. That will allow you to see the type of content that needs to go into every section. What is the general flow of the information? What are the section headings you need to use? And having a previously approved an example from your chair is ideal, because then you can just mirror a similar presentation. So something to keep in mind as well is if you're using previously validated survey instruments, you'll want to obtain scoring instructions for those tools ahead of time. Most instruments that are quantitative and use Likert scales will have scoring instructions. So you might have to email the original authors or do some research online to search for those. Within the scoring instructions, many surveys may have reverse coding. So there might be negatively phrased questions that you need to flip the Likert scale before you analyze the data. So an easy way to pinpoint that is if you have both positively and negatively phrased questions. If that's the case, then you probably need to do reverse coding. And as you're working on the data analysis, You want to keep a running record of every step that you're taking. You can use syntax files in SPSS. I will show you how to use those. And whenever you make a major adjustment to your spreadsheet, whether that's reducing the spreadsheet for non-responses or outliers or any manipulation to the data, I recommend saving a new copy of the spreadsheet. That way you can go back to a previous version if you need to. Okay, so I have a sample spreadsheet here, and we'll go through this concurrently with the PowerPoint. And this is a spreadsheet that I downloaded directly from SurveyMonkey. So SurveyMonkey is a website that you can use to host surveys. And once you've completed the survey and the data collection, you can download the data directly into SPSS. So that's what I've done here. You can download it into really any software, SPSS, R, Excel, Stata, but we're focusing on SPSS today. So within here, this survey was measuring two things. So it has two Likert scale surveys. One is measuring self-efficacy. So we use the previously validated GSE for that. And then we have a 36 item questionnaire called the JSS, and that is measuring job satisfaction. Okay, so we have self-efficacy and job satisfaction. When you receive your data set, it's often a good idea to just eyeball it first and make notes of anything that jumps out to you. So the first thing I notice is that we have a couple participants here that didn't complete the survey. So they may have provided consent and then dropped out immediately after. So likely these two people will come out. I also noticed that there are some people who partially responded. So they completed a majority of the survey, but missed the item here and there. So we'll have to figure out what to do there. And from here, the first things I recommend doing are adding an ID variable to the spreadsheet so every participant can be quickly identified with a number. And the reason to do this is that it allows you to keep a running record of who is staying in the spreadsheet and who is coming out, whether that's for outliers or non-responses. So then the second thing is naming every variable in your spreadsheet. So you want to use short descriptive phrases that identify the variable names. So for instance, if you're using a job satisfaction survey, just put the variable name and number each item like this. You can't have spaces in SPSS. You have to have it all as one phrase. And then the third thing is to add descriptive labels to all your variables and then identify values for anything that's categorical. So in SurveyMonkey or Qualtrics, maybe it's set up numerically for demographics, like 1 is male, 2 is female. So within SPSS, you can make that identification. So let's take care of these first few steps. So the first thing we'll do is add an ID variable. And the way I do that is I'll look at the spreadsheet and see how many people we have, which is 90 in this case. So then I'll go into Excel and start a running count and then autofill it down. So we're just doing 1 through 90. We're numbering and naming everybody with a number. You want to keep it confidential if possible, eliminating the use for names, addresses, phone numbers, that sort of thing. All right, so now we have an ID, and I'll make that the first variable here. Okay, we'll call it ID. The second thing we'll do is name the variables of interest. Okay, so there aren't too many. We have one demographic question here for gender, so I'll just call it gender. And then we have 10, I think it's 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so 10 GSE items. So we'll do the same thing here is just do an autofill. GSE 1 through 10. Then we have 36 job satisfaction items. So JSS1, JSS2. Autofill that to 36. There's not a way to do this in SPSS. That's why I'm doing this step in Excel. And it's kind of easy to just do autofills like this. So these are the variable names now that I'm swapping. Okay, so now all the variables are named. And then add descriptive labels to the variables. This has already been taken care of. So you'll see here's the variable names, here are the variable labels, which is more of a specific description of what each survey item was asking. Within SurveyMonkey, it already captures this. So it's going to take the survey label and the survey question and automatically populate this field. So this step has been taken care of already. We have variable labels, but we need to identify gender. So gender is set up numerically. So we need to identify what was male, what was female. So we go to values right here. And then we're going to add 2 rows. 1 is going to be male and 2 will be female. Okay. So the first 3 steps are done here. The next step is recoding Likert scale items from string format into numeric format. So there's many ways to do this. And to illustrate what we need to do here, for the GSE, you can see that we have the actual words for the responses, exactly true, moderately true, hardly true, but we want the numbers that represent those categories. Very much like the JSS was already converted to numbers. So it had to do with how the survey was set up in SurveyMonkey, is that some responses, it's going to give you a categorical designation, and others will be numeric. So we need to fix the categorical designation for GSE. And while I'm doing that, I'm going to pull up the scoring instructions for these 2 tools, just so we have them handy. So that's what I mentioned on the first slide, is you want scoring instructions for any previously validated instrument, and we'll take a look at those shortly. Okay, so the next step was swapping the Likert scales with numbers. So we need to pull up the GSE, which I have right here. Okay, so we can see that not at all true is a 1, hardly true is a 2, moderately true is a 3, exactly true is a 4. So there's many ways you can do that swapping. You can manually replace it if you have a small spreadsheet, a little tedious if it's larger. You can use the edit, find, and replace function. That is definitely an option. This is my preferred method, is to use a transform function in SPSS. So I'll show you how to do that. So we'll go to transform and then recode into same variables. And then we need to move all the GSE items to this right box. And we need to identify what is going to be a 1, 2, 3, and 4. So I'll go back to here. Not at all true is a 1. Is a 1. So the easiest way to do that is to go in the spreadsheet here, copy. So I'm hitting Control-C, or you can right-click and copy. Then go to old and new values here. We're going to put the old value as not true at all, and the new value is going to be a 1. And then click add, then we just rinse and repeat. The next one is hardly true. So find a hardly true in here, copy, old and new values. This will be a 2. Moderately true is the next one. That will be a 3. And exactly true is the final category. That will be a 4. So we have 1, 2, 3, and 4. Click continue. Now I can click OK, and that's going to run this command. It's going to convert it to numbers. Or I can click paste. So I want you to get in the habit of clicking paste, because paste will generate a syntax file that is basically telling the story of how you clean the data. So within here, and you can add comments. So you just put a asterisk, so shift 8, and then I can say this is recoding string to numeric, or GSE. Okay, so this is the code to run that command. And by the time you're done with your analysis, you might have 20 different commands in here, but it's going to tell the story to an independent researcher. How did you clean the data? So I prefer having syntax versus going into the menus and redoing things multiple times. Syntax is much more efficient. So to run the syntax, we'll then highlight this code and click this green arrow, and you'll see these are going to change to numbers like that. Okay, so now it's converted to numbers. It's almost ready to go. However, SPSS still thinks these are string format variables, which means the software thinks that these are words still. So we just need to change it to numeric manually like that. And then I can copy that numeric and paste it for these other items. So now every item's numeric. Okay, so we've taken care of this step, converting Likert scale items from string to numbers. The next step is looking at missing data. Okay, so before we get there, let's save the spreadsheet. Okay, we've done a number of things here. So let's save it and be descriptive with the steps that you took. So here, what I would do is put the sample size. So we have 90 cases. And I would just say ID added, string converted to numeric. Okay. Then the next step is dealing with missing data. So there are many ways to handle this. And if you're way above your sample size requirement, maybe you did a power analysis in your methodology and you gathered way more participants than was required, then I think you have room for error in that situation, and you can consider deleting any missing cases. If you need to try and retain as big of a sample as possible and eliminate removals, then you can consider replacing missing cases with the average or the median, or you can use more complex techniques like imputation. Okay, so let's take a look what we had here. If people consent and then drop out, you usually want to remove those people if they don't answer anything. So these two people, they didn't even answer the demographic question for gender. So I would take these people out. Okay, so those two will come out. I'm just highlighting the two rows, right-clicking and clear, and keep a running record of this. So we'll call it, data cleaning. This is a Word document, and you can say the initial sample size was 90, and we had 2 cases for non-responses. Okay, so now we're at 88. So I would save the spreadsheet again. Now we're at 88. Reduced for non-responses. All right, so that step is partially done. So then we need to look at the people who responded to a majority, but might have missed an item here and there. So there aren't too many of those. Most people completed the whole survey, but there are a few cases here. So what I tend to do is compute a median for these columns and then swap the missing values with the median. The average is also used. You can find references to support the median, the average, even the mode. So to do this, we'll go to transform and then replace missing values. Let's see, that opens up this menu here. So we need to move all the GSE items to this right box. The GSE is the only part where people missed items. The JSS was completed. The entire survey was completed. So we don't have any missing cases there. Okay, so from here, we need to select, I'm going to do a median for this example. So you select a median of all points. Okay, so once I click paste, we're going to have the syntax for this command here. Okay, so this is the syntax for swapping missing values with the median. Okay, so we'll run this. And what this is going to do, it's not going to just swap them here. It's going to create 10 new variables at the end of the spreadsheet that have the variables swapped. So it's going to keep this original 10 item GSE in here, which is good. I think it's good to have both. So we'll run this syntax. And you'll see as I scroll to the right, here are the 10 original items. And as I keep going to the right, you'll see it repeat. So here's GSE 1, the underscore 1, wherever you see underscore 1, that is the backup that has been replaced with the median. So let's find an example here. So this first person missed number 9. As I go to the right, that missing value has now been replaced with the median, which is a 2. Okay, so that's good. Okay, another thing you'll want to do, just like I showed you how to add the values for gender, so 1 is male, 2 is female, you want to do a similar thing for the Likert scales. So again, go back into the scoring instructions. Having multiple monitors is really ideal for data analysis. Having just one can be tricky, so try to use 2 monitors at least. So what we'll do here, we'll go to the first item, add 4 rows, 1, 2, 3, 4. So 1 was not true at all, hardly true, moderately true, exactly true. Okay. So we take that, I'm copying it and then pasting it for the other 10, the other 9 items. And then we need to do the same thing for the JSS. So the JSS I have right here. And you know, the Likert scale, I would have to go into SurveyMonkey to find out for sure, but the Likert scales for this one were not presented. So I think it was like 1 is strongly disagree, 6 was strongly agree. You don't have to have these labels, but it can be useful just to see how the Likert scale was set up. Okay, so the next step, we've taken care of this, replacing missing values. The next thing we can do is create composite scores. So this is really the crux of the data analysis, is creating the variables that you're going to use to address your hypotheses. All right, so this is where you need the scoring instructions, and we'll look at the satisfaction, or we'll look at the self-efficacy one first. So these are the instructions right here. The total score is calculated by finding the sum of all the items, and then it gives you a range of possible scores. So higher scores indicate more self-efficacy. All right, so to do this, we need to take a sum of all 10 items. We'll go to transform, compute variable. We'll give it a name, so self-efficacy. And then we need to take, this is very important, a sum. So you want to take a sum, not an average. So we'll put sum here. And there's a couple ways you can do this. You can put every item in individually like this and put commas in between. It's a little tedious. You can just put the first item, write the word 2, and then put the last item like that. And again, we're going to click paste. So we have the syntax. And here's the syntax for that. We'll do the same thing for job satisfaction. I do see that we might have a question here. I'm going to do a Q&A at the end, but if you have any questions, you can type them into the chat box and I'll take a look, okay? Okay, so the JSS, what are the instructions for this one? So the instructions for the JSS are to sum responses for all the items. So it's the same instructions. So there's a total satisfaction score on the JSS. but there are also subscales. Okay, so you can see the total uses all 36 items and the subscales use 4 items each. For today's illustration, we're just going to use the total score. But keep in mind that when you're doing your analysis, there might be subscales that you're interested in examining. All right, so we'll take a sum of JSS 1 to JSS 36, like that. Okay, so something I should have pointed out earlier is now that we have 2 copies of the GSE, so we have one that has the missing values in there, and then we have the GSE with the missing values replaced. So for the sake of simplicity and not getting confused, I'm going to delete the original. So we'll take out these ones just so we don't get confused. And we'll only use these GSE items with the underscore, okay? So I did self-efficacy already, but I incorrectly used the original items. We need to use these ones. All right, so we have the syntax for the variables. I can highlight this, click the green arrow. And there's one other thing that we should have checked before that. So let's look at the scoring instructions again. So early on in the presentation, I mentioned reverse coding. So that's something that we missed here, is that if there are negatively worded items, you have to flip the Likert scale. And that is the case with the JSS, that there are negatively phrased job satisfaction items. So we need to reverse code. So let's do that step first. We'll go to transform. Okay, so I talk about that here. Identify if reverse coding is necessary. Figure that out fairly early on. If you're in the methodology, know if you need to reverse code or not. It's a fairly crucial step. Okay, so from here, we'll go to transform, recode into same variables. And then you'll see these are the items that we need to flip the Likert scale for. So you just go through them, 2, 4, 6, 8, 10. It's every other one for the first half of it, 14, 16. And I'm just holding control on the keyboard to select multiple items like this. And then move it to the right. Okay, just double check it. Okay, so from here, we'll go to old and new values. We look at what the Likert scale needs to flip to. So 1 becomes a 6, a 2 becomes a 5. It's just inverted. So 1 becomes a 6, 2 becomes a 5, 3 becomes a 4, and so forth. So 4 becomes a 3, 5 is a 2, 6 is a 1. Okay, so it should go up the ladder 1 through 6, and then down the ladder 6 through 1. Continue and paste. So this is reverse coding the JSS items. So we will run that. Okay, so now that's been taken care of. I would recommend at this point putting an R next to the items. I've run the command, so it's good to know which ones were flipped. So R means reverse. 60. Okay. Okay, so that is the important first step. You have to reverse code first and then compute the composite score. So we'll do job satisfaction here again. And this is going to be a sum of JSS 1 to JSS 36. and then click paste. Okay. All right, so from here, let's save the spreadsheet. We've done a number of things. So we created composite scores and added values. Okay. And then let's save the syntax as well. Okay, just bear with me for a minute. I have to reboot SPSS real quick. And for the GSE, you can see that there was no reverse coding necessary for this one. So sometimes it won't even say like this, which is frustrating, but you have to read the questions very carefully and see if there are positive and negative phrasings. All right, here we have SPSS rebooted. Okay. And you can see the running record now. So we have the first spreadsheet, and then you can see the steps that we're making to reduce responses and create composite scores and so forth. Okay. All right, so we have taken care of creating composite scores. The next step is the beginning of running your primary analysis. So assuming you have research questions and hypotheses and they've been approved, you probably know what analysis you need to run. But before you run that actual analysis, there are prerequisites that the data needs to meet to run the test. So there are things like normality and linearity and homogeneity of variance. Those are called assumptions. So this is a great website to check that will identify what assumptions you can verify. So for instance, say we're doing a linear regression and I want to know what assumptions to check. You can type linear regression into Google and then just put statistics layered at the end. I see a lot of universities are using this website now, especially GCU. So the website will go through how to run a linear regression and what assumptions you should check. So some assumptions are definition based and they aren't things you have to statistically verify. So for instance, these two assumptions here, your dependent variable should be measured at a continuous level. That's not something you statistically verify. It's more how you collected your data. Is it continuous? Is it categorical? Is it ordinal? And the same idea for this one, your independent variable should be continuous. Same idea. That has more to do with data collection as opposed to data analysis. And then it goes through more objective and subjective assumptions. So linearity, you can check with scatter plots, outliers, you can check multiple different ways. I think this website sometimes goes a little overboard. They have too many assumptions listed when not every assumption is really of utmost importance. But check with your committee. They might have a preference for what assumptions you verify. Okay, something to keep in mind is that some assumptions are definitions, as I mentioned, others need to be verified. Many assumptions give you a p-value. So if you're doing things like Shapiro-Wilk tests or Kolmogorov-Smirnov tests or Levine's tests, it gives you a p-value that will ultimately tell you, is the assumption supported or not? And if the p-value is greater than 0.05, that's actually a good thing for these tests. Usually in statistics, you're hoping for a p-value lower than 0.05, which would mean a significant result. But for assumption checking, it's the opposite. So that's an important thing to keep in mind. If assumptions are not supported, then you can consider running a backup test. And those are called non-parametric analyses. So parametric analyses are things like Pearson correlations, independent t-tests, paired t-tests. they're parametric, and what that means is that the data has underlying assumptions about how the data is distributed. So when you do parametric analyses, you usually need to have a normal distribution or a bell-shaped curve for your data. If that is not supported, then you can consider running a backup. And most parametric analyses have a non-parametric alternative. So in this case, if you proposed a Pearson correlation and the assumptions were not supported, you could proceed with a Spearman correlation. And likewise, if you proposed an independent sample t-test and the assumptions are not supported, you could consider running a Mann-Whitney U-test. So if you take a look on Google, you can see what is the backup approach for every test. All right, so we'll dive into some specific assumptions here. One of the major ones is assessing for outliers. So there's a couple different ways you can do that. You don't necessarily want to keep them in, but some committees will want you to keep them in. It's kind of a tricky one because you don't want to eliminate cases if it's going to reduce your spreadsheet. You want to keep everybody in if possible, even if they scored extremely high or extremely low, because that's maintaining a realistic picture of how people perceive things. But sometimes you do want to remove outliers, and this is the method I tend to follow, is standardizing the variables, essentially creating z-scores and then removing high and low z-scores. So to do this, we would need to check for outliers on self-efficacy and job satisfaction. So we need to standardize these values. And to do that, we'll go to Analyze, Descriptive Statistics, and then Descriptives. And then we'll move self-efficacy and job satisfaction to the right. And we're going to check mark this box right here, Save Standardized Values as Variables. Once I click OK for this, it is going to create z-scores. I accidentally did the ID as well. We didn't need that. So we have self-efficacy and job satisfaction z-scores. So these are standardized in relation to the average. And according to the citation, if a z-score is larger than 3.29 or lower than negative 3.29, that is considered an outlier. So the easiest way to pinpoint those is to sort these columns in ascending and descending order. So if you right-click, sort it in ascending order, the lowest z-score we have for self-efficacy is negative 1.99. That does not exceed negative 3.29. So we don't have any low outliers for self-efficacy. Then we sort it in descending order to bring the high scores to the top. And this is the highest z-score we have, 2.19. So 2.19 does not exceed 3.29, positive 3.29. So we don't have any outliers for self-efficacy. Then we do the same thing for job satisfaction, sort it ascending. This is the lowest z-score we have. It's not exceeding negative 3.29. Then sort it descending. We do have a couple cases here. So some people, you can see their actual scores. These two people scored well above the rest. And these z-scores are greater than 3.29. So personally, I would take these cases out because they might skew the findings of your analysis because these people scored way above the rest of the sample. So I would take these cases out. We'll right click and clear and then save a new copy of the spreadsheet. So this has 86 and we've removed 2 outliers. Okay. So that's the way to look at outliers. You can also do histograms or you can do box plots. That's another way. So if you go to Analyze, Descriptive Statistics, and Explore, this will generate this box here. Move self-efficacy and job satisfaction to the right box here and click OK. Okay, and this is a huge output. It gives you a lot of stats at the beginning about the mean, standard deviation, min, max, that sort of thing. And then we have box plots. Okay, so here's the box plot for self-efficacy, and here's the box plot for job satisfaction. I don't tend to use this because SPSS uses a different cutoff for what is an outlier. I tend to use this citation here, which is an important thing to note, is that you don't want to use multiple methods for checking assumptions. You just use one method. You could see contradictory findings if you use multiple methods. So just pick one method and justify proceeding with that method. All right, so from here, let's look at some sample research questions and what are the type of assumptions that I would check. So the first sample research question we have here is there a significant relationship between job satisfaction and self-efficacy? So the first thing I do is I look at the variables of interest and what is the level of measurement. They're both continuous, they're both numeric, and we're looking at a relationship. So we likely need to do a Pearson correlation here. And when we're doing a Pearson correlation, this is when you could go to statistics layered. So Pearson correlation, statistics layered into Google. And this will tell you what assumptions you should check. So the first one is that the variables are interval or ratio. That just means continuous. So that's a definition and that is supported. The second assumption is that there's a linear association between the variables of interest. So we need to run a scatter plot to figure that out. All right, so to do this, we'll go to graphs and then chart builder. And from here, we need to select a scatter plot template, which is right here. Click and drag a template up to here. And then we need to put our variables into the X and Y axis. So self-efficacy, we'll do job satisfaction on the X and then self-efficacy on the Y. And then click OK. And this will give you a scatter plot. So you can see what is the visual association between job satisfaction and self-efficacy. What we want to do is draw a summary regression line that summarizes the relationship. And to do that, you just double click the plot. That brings up the chart editor here. And then we're going to go to elements and then fit line at total. And that is going to draw a summary regression line that shows the directionality and the slope of the relationship. So what we see here is that there's, potentially a slight positive association, and the slope is pretty small. It's not a large steep, but we might have a slight positive association here. So that's the first assumption. And something to keep in mind here is SPSS does not adhere to APA requirements. So, things like removing bigger titles like that, putting spaces between variable names, those are things you have to do manually within this chart editor. And then having colors also something APA doesn't always agree with. So you can change things to gray, black, or whatever. It should be grayscale, typically gray or black. Okay. So that is the linearity assumption. This is probably the most important assumption. As I mentioned earlier, if you're doing parametric analyses like t-tests, regressions, ANOVAs, normality is a pretty big requirement. So what you need to do to check for normality, and there's many ways to do that. You'll go to Analyze, Descriptive Statistics, and Explore. We were already in this menu to do the box plots, but there are some options we can select. So we'll go to Plots right here, and then we will select this option, Normality Plots with Tests, and then I would also check mark histogram. That's going to give you a visual interpretation for normality. We'll click Continue. And I'll click paste for this one. So we have the syntax. All right, so the note for this is checking for normality. So highlight the code, click the green arrow. And the two predominant tests, and these are objective tests as opposed to subjective interpretations. So these tests are for normality. You have to pick and choose one of these. I would not recommend reporting both because, again, you could see contradictory findings between the two. So as I said earlier, non-significance is ideal for these tests. You want to see a p-value greater than 0.05. If the p-value is lower than 0.05, which is underneath the significance column, then we do not meet the assumption. So we can see for self-efficacy, the p-value for both the Kolmogorov-Smirnov test and the Shapiro-Wilk test were above 0.05. So normality was supported for self-efficacy using both of these methods. And for job satisfaction, the p-value is below 0.001 for both of these tests. So normality was not supported for job satisfaction. I tend to use Shapiro-Wilk for this. It's just a more recent version, I believe, compared to the Kolmogorov-Smirnov test. But you can also use histograms to visually interpret normality. The problem with that is that everybody is going to interpret a histogram slightly differently. So when I look at this histogram, this does, you could draw a bell shape around this. It does follow the general shape of a bell curve, where it peaks in the middle and the legs, the tails are kind of lower. So self-efficacy looks good. When we look at job satisfaction, this one looks good on the left side, but it skews to the right. So this is likely why normality was not supported, is because we have a few scores that were quite high and it tails off to the right. Okay, so this is called a right skew. Based on those findings, and primarily based on the Shapiro-Wilk, let's just go with the Shapiro-Wilk as the primary interpretation here. So normality was supported for self-efficacy, and it was not supported for job satisfaction. We do not have unanimous support for normality. So in this case, I would run a non-parametric backup. I would do Spearman correlations instead of Pearson correlations, or do Pearson correlations and report Spearman as a backup. Okay, so to do that, we would go to Analyze, Correlate, Bivariate, and then put in self-efficacy and job satisfaction. And you'll see the options down here. So Pearson by default is selected, but because normality was not supported, we are going to do a backup, and that is a Spearman correlation. We'll click paste. Now we have the syntax for this. So this is the Pearson correlation. And this is the backup Spearman. And you just highlight and run, and you'll get your results. So ultimately, both the Pearson and the Spearman correlation were not statistically significant, which means that there's not a significant relationship between job satisfaction and self-efficacy. Okay, so that's one example. The second example we have here is a test of differences. Okay, so is there a significant difference in job satisfaction between males and females? All right, so we have the job satisfaction variable, as we've used a couple times already, and then we have a gender variable. Okay, now when you're comparing a continuous variable between two groups, that's when you tend to do an independent sample t-test. Okay, and again, let's go into Google, put independent t-test layered. And let's see what assumptions are checked here. So the first two are definition based, is that your outcome should be continuous. Job satisfaction is a continuous variable. Your independent variable needs two discrete groups, which we have, male and female. You should have independence of observations. That just means that there can be no overlap between the groups, that participants can't be in multiple groups simultaneously. That is supported here. There are no significant outliers. We checked for that early on, and we've already removed 2 outliers. And then we get into the big ones. Okay, so the first big one is normality, which we've already checked. We checked for normality here and say that we're proceeding with only job satisfaction. So if we were only using job satisfaction, normality was not supported here, so you should likely run a non-parametric backup for the job satisfaction gender comparison. All right, so first we'll do the original t-test, and we'll go to analyze, compare means and proportions, and then independent sample t-test. From here, we will put job satisfaction into this box, and we're going to put gender into the grouping variable. Before you run it, it actually doesn't even let you run it right now. You have to define your groups, and all that is just clicking define groups, and we have 2 groups, 1 and 2, like that. And then click paste, so we have the syntax. All right. And what do we see here? So for the t-test, one of the assumptions of the t-test, again, we checked for normality already. This is the second assumption of the t-test, homogeneity of variance. And this is verified with a Levene's test. So the easy thing about this one is it's built into the t-test. So we just ran the t-test, and Levene's test is right here. So this is the second big assumption, and the assumption was not supported. So we can see the p-value is below 0.05. So the assumption for homogeneity of variance was not met. When that happens, you then do not interpret this top row for a t-test. You interpret the second row. So equal variance is not assumed. This is the row that you would report for your t-test. And what we see is that the p-value is significant, meaning that males and females had significantly different job satisfaction levels, with females having higher satisfaction compared to males. All right, so I think we checked every assumption here. We checked for outliers, we checked for normality. So normality was not supported for job satisfaction, and we just did a t-test. I would run a backup. So the non-parametric backup to a t-test is a Mann-Whitney U-test. It's quite a lot of menus to find it. So non-parametric tests, legacy dialogues, and then 2 independent samples. And this is set up the exact same way as the t-test. So put job satisfaction here, put gender here, define the groups as 1 and 2, and then click paste. Okay, and then this is the backup approach, the Mann-Whitney U-test. So you might not have to report both. You might just need to report one. This is highly dependent on your committee and how strict they are with assumption checking. Some committees really don't care at all, but some are very adamant about checking for assumptions. So it's going to be their preference and your school's template. Your school's template might say to check for certain assumptions. Okay, so from there, after you've cleaned the data, you've checked for assumptions, you then will want to work on the write-up. So follow your school's template for chapter 4. Or if you're doing a journal publication, look for a previous journal that's been approved so you can mirror that presentation. You want to start out with a description of your sample. How many people did you have? How many people were removed from the spreadsheet for whatever reason? Not meeting inclusion criteria, not meeting assumptions, outliers, non-responses. You want to have a descriptive paragraph to describe how you got from your initial sample size to your final sample size. And then you want to run a demographic examination, for gender, ethnicity, education level, and then run descriptives on any variables of interest. Then you can address your research questions with your primary analyses after you've checked for assumptions, and then present the write-up according to your template. All right, so do we have any questions? I know we had a hand raised. If you have any questions, you can type them into the chat box, and we'll send everyone a copy of the recording following this session. Do we have any questions? Anything that you'd like me to review again? It's good to see some familiar names in the webinar. Any questions?
Justin, there's a few in the Q&A.
Oh, I was looking at the chat. That was my mistake. Okay, let's see. All right, our first question. I'll move these to a Word document. Okay. All right, we have a question from Angela. What is the difference between recoding same variable versus different? That is a great question. So let me illustrate. I use both, to be honest, and it depends on the situation. So if you do recode into different variables, hypothetically, let's say we need to reverse code this question. So recode into different variables is going to create a copy of the same variable. So it's going to keep this one in here, but then we need to create a copy. So I'll just call it copy like that. And then you specify your old and new values. Say we are doing the same reverse coding. 1 became 6, 2 is 5, 3, 4. Okay, so this is recode into different variables. If I run this and let's see why. Oh, okay, so if I run this, this is going to keep this original variable in here, but at the end of the spreadsheet, you'll have the reverse or the copy of the different variable. So that's the difference. Recode into same variable, that's what I did initially for this component, the reverse coding. But I just signified that reverse coding was done with an R at the end of the title. All right. Okay, we have another question here. Okay, by replacing missing values with the median, aren't you potentially reducing the effect of the relationship? Yeah, it's one of the limitations of missing data. It reduces the effect, potentially the power, but there are, you can replace with the median, the mean, you can use predictive imputation, you can eliminate missing values altogether. If someone's missing even one question, you could take them out if you have a large sample. This is just the method that I've seen used the most at universities, is that they just swap missing values with the median. Okay, we have a question from Allison. In the case of a correlation testing with 2 scales, as you demonstrated with normality, which test results should I report? Am my results parametric or non-parametric? I've seen it done every which way. I've seen people, so the 3 options are report only parametric and use your sample size seeding. Okay, so the first method is even if assumptions are not met, like normality is not supported, you can still proceed. And if your sample size is large enough, that gives you justification to proceed. And that's called the central limit theorem. The second method would be report only the non-parametrics. I see that used quite often too. If assumptions are not supported for parametric, then only report the non-parametric. My preferred method is to report both. So report the Pearson first, then report the Spearman as a follow-up with further evidence. All right, so those are the three options, I think. And I tend to go with this one. I tend to report both, but that's going to be dependent on your committee. Okay, we have a question from Sarah. Does syntax automatically save and reopen when you open your data set, or should that be saved separately and often? It's a separate document altogether, so syntax will need to be saved separately. And whenever you use syntax, make sure that you have the corresponding spreadsheet open as well. So you need to have this data set open to use the syntax. Otherwise, it won't know, the software doesn't know where to link the syntax to. So have them both open and close every other spreadsheet so the software doesn't get confused about what syntax is being used or what spreadsheet is being used. Okay, we have a question from an anonymous attendee. Let's see. Okay, do you do thesis proofreading, full document as a whole and not each chapter? Yes, we do proofreading. So we have APA editors. It actually depends what format you need to follow, but yes, we do proofreading, predominantly APA editing. Okay. Here we have a question from Tamuno Kuro. Since I have independent variables, job satisfaction, it's interesting that we have the same variables that we use today, and 3 independent variables. How do you run the test using the Durbin-Watson? Okay, so this, I'm assuming you meant dependent here. So for Durbin-Watson, I can illustrate that. So I'm assuming you're running a linear regression. So you need to go to analyze regression, then linear, and then say, I'll put in, for illustration purposes, we'll put in gender and we'll put in job satisfaction as predictors, and then self-efficacy is your dependent variable, or just to keep it consistent with what you have. Job satisfaction is the dependent. Okay. Okay, so you said job satisfaction is the dependent and you have 3 independents. So say you'll have job satisfaction up here and then your 3 independents here. Then you go to statistics and Durbin-Watson is right here. Okay, so you'll click continue and okay. And SPSS, I think it just froze on me. But once you run that, you will see the Durbin-Watson command. Ideally, that value needs to approach 2. So 2.00 is kind of the number to aim for a Durbin-Watson value. All right, some great questions. Do we have any follow-up questions? Oh, I see one right here. Okay. Question from Mahi. Okay, so I did an experimental design study. Second. Okay, I did an experimental design study, quasi-experimental. There are 2 groups, an active control and a mindfulness intervention. Tests that pre, mid, and post. What was the assumption that was not supported here? Okay, so you're not looking here. Here's a follow-up comment. Okay. I don't know if ANCOVA would be the solution for this. If assumptions are not supported, I suppose it depends what assumption was not supported. But going from ANOVA to ANCOVA, they're both parametric alternative to an ANOVA. You might have to do Kruskal-Wallis tests. That's the non-parametric version of an ANOVA. You're not looking at the effect of time, but to look at the effect of the mindfulness intervention. Okay. All right, I think I just need to visualize this. So you have treatment versus control. You have pre versus mid versus post. I suppose if you're not looking at time, what was the point of doing pre, mid, and post? I think that's a pretty big question, is if you have these time points, I would be assessing for differences within effects over time. But, you know, if assumptions were not supported, how many dependent variables do you have? So I guess you have 3. So pre, mid, and post. And if assumptions are not supported, consider. Okay. Okay, so from here, if the assumptions are not supported, I would do a Kruskal-Wallis test for each of the stages. So pre, mid, post. And it's actually only 2 groups. So I didn't mean to complicate this. It's actually just a Main-Whitney-U test. So Main-Whitney-U, if it was 3 groups or more, you would do Kruskal-Wallis. But with only 2 groups, you'll do a Main-Whitney for pre-test between treatment and control. You'll do a Main-Whitney for mid-test, treatment and control, and then a Main-Whitney for post-test between treatment and control. So if assumptions are not supported, I would just do 3 Main-Whitney-U tests. Okay. All right. Do we have any other questions? Yep, you're welcome. All right. Do we have any final questions? All right. Thanks for joining, everyone. We'll send the recording for this session, and keep us posted if you have any questions about the process. If you're stuck in the dissertation journey, we can certainly help to expedite the process. And just let us know if we can be of any assistance. Have a great day. Take care.